Hey, and welcome to Chapter 9. This is Python Dictionaries. My favorite chapter in the whole book is files because that's where it sort of comes together. This may be your favorite chapter. Python dictionaries are one of the things that people sort of fall in love with in Python. It's like, oh, I can do so many things with dictionaries. And dictionaries are our second data structure, our second kind of collection. And the basic definition of a collection is more than one thing in a single variable and a way of indexing and looking up and manipulating things in that single variable. And so we have the list, and now we have the dictionary. And between lists and dictionaries, you pretty much get the two most important and most basic data structures, not just in Python, but in any programming language. So to review, the idea of a collection is we put more than one thing in, whereas a regular old variable that's not a collection, a non-collection variable like x, we stick a 2 in, we say x equals 4, and we sort of implicitly know that now it has a 4 in it. But the 2 is long gone. It's been overwritten. So the two collections we've talked about, the list is a very ordered collection. Everything is very precise, 0, 1, 2, 3, 4. You append at the end. And when you start deleting, it always stays compacted, and the position is the key to it. But a dictionary is more of a mess. You put things in and you give them a label and you get things back out. And so they don't always stay in order. The order shifts around, but they're super powerful because it's a key value pair. And you give each item a key, you give it a key on the way in, and you get a key on the way back out. And so inside of a dictionary, everything has to have a label. You can't just put something in a dictionary. You have to give it a label and a value, or a key and a value. And so the key is, when we say key, it's like the thing to unlock or thing to find that thing. It's a general concept in many languages called associative array, and you can kind of look up and learn a bit more about associative arrays. And in most languages, like Perl or PHP, the associative array is, again, most people's favorite data structure because you can do so many things with it. So dictionaries are Python's most powerful collection. It's like a little baby database. Key value, you look something up, your name and a phone number, or a phone number and a name, but there's a key and a value. And like I said, these concept of dictionaries has many different names in many languages, like hash maps in Java, or property bags in C#, or associative arrays in Perl or PHP. But they are the same thing. They're memory-based key value stores. So, like I said, the whole idea of these collections is they have more than one thing, but the question is how you put stuff in and how you get stuff out is what changes. And so here we're going to make a dictionary, and this is a constructor that basically says, make me an empty dictionary object. If we're doing this with a constant, we just use curly braces. Curly braces are for dictionaries. So pers is a variable of type dictionary, and it now has nothing in it. Whereas in the list we had to append stuff, we use the index operator on the left-hand side of an assignment statement to indicate the key. So this ends up being the value, and this is the key value pair. And so we're putting 12 into the purse, but on the way in, we're labeling it with money, right? And so 12 is going in, 12 is the value, and we're putting it into purse, but we're storing it under money. So I would say this as purse sub money equals 12. Money is the label, the index, the tag, whatever you want to call it. But it is the way we're going to label this number 12 as we go in. And we're going to put 3 in, and we're going to label it candy, and we're going to put 75 in it, and we're going to label it tissues. So inside a purse, we have these key value pairs. Say, hey, what's in purse? Well, money is 3. Under the tag tissues, we have 75, and under the tag candy, we have 3. It's important that the order of these dictionaries is somewhat unpredictable. They don't always come out in the same order. And so we'll have to learn later about how to sort them and how to do stuff to them. But they think of them as, for now, as an unsorted bag of values. But it does remember, no matter how they get moved around, what the label to value mapping is. To pull something out, we say purse sub candy. So we use the exact label that we use to put it in. We use that to pull it back out. So purse sub candy is 12. So it says go look up and find in this dictionary the thing that has a key of candy, and then pull that number out. So that's the number that comes out and gets printed. We can update these variables. The dictionary contents are mutable, which means they can be changed. So we can go grab the old value of purse sub candy, which is a 3, add 2 to it, and then put a 5 back in, and then we can print this out, and then the 3 has been modified to become 5. So we can use them on right-hand sides of expressions, on left-hand sides of expressions, away you go. So it's really a lot like lists. If we look at an example from a previous chapter on these lists, we make an empty list, we make an empty dictionary. We add into position 0, which is because it's empty, a 21, and we put in position 1 and 183. Here we put into this dictionary under the key age 21, and into this dictionary under the key course we put in 182, right? And if we print them, we see that there is an implicit position 0 and position 1. There's an implicit position, so we don't have to show the position. I mean, Python could choose to show that, but it doesn't. And then if we print it, a dictionary, it shows us with curly braces to say this is a dictionary, not a list. And it uses this key colon value. And order, again, isn't the same. We put in age, then course, and we got out course, then age. Just don't expect the order of dictionaries to be a predictable thing. And then continuing on, they're mutable, which means we say list sub 0, and this is the index. So in a list, the index is the position, and we put a 23. We put a 23 into position 0, and so when we see that, we see a 23 coming out. And here, if we're going to change something, we're going to say, oh, go find that thing marked with the tag age and replace that with 23. So that puts the 23 in here and replaces it with 23, and so when we print that out, we get 23. But basically, they're similar, but dictionaries have these labels that we have to use everywhere, and lists have positions. So lists are compacted. They always start at 0, even if there's none in there that doesn't start at 0. But if there's one or more things, the first one is always 0. And while we haven't deleted stuff from lists, once we start deleting stuff from lists, they get compacted. But not true from dictionaries. They just kind of remove the key because they're not particularly in any order anyways. So again, we can see this all happening. I like to think of in my mind a picture of these things where a list has kind of a key or the way we look something up. It's 0, 1, and if there were more of these, it would be 0, 1, and 2. Whereas a dictionary, the key is some kind of a string. This is how we look it up. And then they both have values, right? They both have values in them, and that's how it works. And so when we put these things in, the list gets extended. It's always going to be extended at the end. If you called append again, there would be a sub 2 in here, and they put some number in there, and we print them out. And then when we go and change this 23, we put it in here, it gets wiped out. They're mutable, which means these values are mutable. The keys are sort of not in lists. The keys are simply an artifact. You can't change them, but you can delete items. You can delete items from lists, which we haven't done yet, but we will be able to delete items from lists. And so the same thing is true. We can delete items here, which we haven't done yet, but you can also change them. So dd sub age, we'll go look up age and then stick 23 in there, and that's changing. So they're very similar structures. The key difference, the significant difference is that the key mechanism, the way we look up an entry inside the collection, is different between them. We can make constants, and the printouts of these things conveniently in Python show us the constant syntax. So it's like, what's in this dictionary? So we start with a curly brace for a constant, curly brace, and then we have key value, key value, key value. Now, I have been using strings for keys and numbers for values, which is actually a pretty common shape, but doesn't have to be that. So just because I'm using it doesn't mean that's always that way. So this creates a dictionary constant, and then that gets assigned in the JJJ variable. Just like it's no different than saying x equals 3, this is an integer constant that gets assigned into x. We print it out, and it looks exactly kind of the same, but the order is different because dictionaries mess with order. You can make empty dictionaries with just curly braces and print those out as well. So up next, we're going to start talking about the kinds of applications that we're going to use, the kinds of problems that we're going to solve using dictionaries.